Okay. In today's lecture, I will explain you what is frequency modulation and what is the how we derive the equation of the frequency modulated waveform, right? Like we discussed earlier in amplitude modulation, that amplitude of a carrier signal is varied according to the message signal. But in frequency modulation, frequency of carrier signal is varied according to the message signal, right? And third thing will be phase modulation. When we will be discussing phase modulation, that means the phase of the carrier signal is varied according to the message signal. So we can write the equation for the frequency modulation. So FIT equals to FC plus KFMT. Okay, let us say this is equation number 1, right? So FIT is basically the instantaneous frequency. Basically, it is Fi, instantaneous frequency in time domain, right? FC is the carrier frequency, MT is the message signal, and KF is the frequency sensitivity. So this is the equation of the instantaneous frequency. Okay, because our instantaneous frequency is changing according to the carrier signal, right? Basically, instantaneous frequency of carrier signal is varied according to the message signal. Okay, so these all terms are in this equation. Okay, now the waveforms. Okay, so when we are drawing the waveform, so we know that when we are drawing the waveform, so it is basically message signal. So I can say it is MT. This is my message signal, and as we discussed in the amplitude modulation also, it is a sinusoidal waveform, or it can be any waveform, right? So the amplitude of this is AM, and I can say it is minus AM, the peak. Okay, now this one is the carrier wave, so I can say it is having a frequency FC, and the carrier wave is basically AC. The amplitude of carrier wave is AC, right? So I can write it is a carrier wave. It is just similar as we discussed in the amplitude modulation waveform. This is my message signal, right? Now, how to draw the frequency modulated wave? This is my frequency modulated waveform, right? So I can say it is phi FM. Okay, so this is my phi FM. So phi FM means, like we did in amplitude modulation, phi AM, right? We are doing here phi FM. Okay, so how to draw the frequency modulated waveform? Now as you see, when the message signal is positive, okay, so the frequency of the carrier signal is high. So you can say these are very close to each other, right? So the frequency is high. Okay, but when the message signal is negative, so on the negative side, you can see now the frequency of the carrier wave is changing. It is low. So we are making this apart from each other, right? So this here the frequency is low, and here the frequency is high. Okay, and again now the positive here message signal, and now the frequency you can see it's high again. So now from this figure you understand this equation. Frequency of carrier signal is varied according to the message signal. So we are just looking at the message signal, and the frequency of the carrier signal is varied according to the message signal. Okay, so we can say there is no change in amplitude. Like in amplitude modulation, what we have done in amplitude modulation, there was a change in amplitude according to the message signal, but now there is no change in amplitude. It's only the change in frequency, right? So that's why this is my frequency modulated waveform. Okay, now the most important thing is how to derive the equation of the frequency modulated waveform. Okay, so first of all, I will write phi am, sorry, not am, it is fm. So I can write what is the phi fm, that means frequency modulated waveform. So it will be AC, the amplitude of the carrier wave, cos phi I t. So phi I, or maybe I can denote it with theta I. Theta I will be better. So it is theta I t. Okay, so because the frequency is changing, okay, so that's the equation of the frequency modulated waveform. So let us say this is equation number 2. Okay, and we all know what is the equation of the message signal, because message signal is just the message signal, or we can say it is also known as modulating signal. This is the carrier wave and this is the modulated signal. Okay, so message signal, because it is a normal sinusoidal waveform, so I can write am cos 2 pi fm t. Okay, let us say it is equation number 3. So we can take any cos waveform and sine waveform as well. It's up to us. Now we need to derive the formula for this equation. Okay, so how to do it? So first of all, what I will do, I will just find out the value of theta I t. Okay, how to find out? So basically we all know angular velocity equals to angular displacement over time. Okay, we all know this formula, right? What is angular velocity? Basically, we all know the formula of velocity. It is velocity equals to displacement over time. But if we are speaking about angular, that means angular velocity equals to angular displacement over time, right? So I'm just denoting it with omega equals to angular displacement over time, right? I can write it like this. Let us just make it a bit clear. So it is omega, right? So I can write it like this. Now I need to find out the value of theta I, right? So how to find out the value? Can I write it in this form? D theta I t over t equals to omega I t, right? I can write it in this form. Now what I will do, I will integrate both sides. Okay, so let us say it is 0 time interval t, and it is this over t equals to 0 time interval t. Okay, let us integrate these both sides. So if I integrate this in time interval t, then it will give me simple theta I t, right? Now to integrate this, we all know omega equals to 2 pi f, right? So in place of this omega I t, can I write it 2 pi f I t dt? Can I write it like this? Okay, now theta I t equals to 0 to t 2 pi. Now what is fit? Look at this equation now. What is fit? It is equal to fc plus kf mt, right? So I will just place the value of this here. Fc plus Kf mt dt. So I'm writing here by placing value of Fit from equation 1. Okay. So now I'll get this equation. Okay. Now again come back to this equation. Theta it equals to 0 to t 2 pi fc dt plus 0 to t 2 pi fc k, not fc, it will be 2 pi kf mt dt, right? So this will be the equation. Now I have to integrate it. So if I will integrate it, it will be 2 pi fc and dt integration is 1. And if I will put the limits here, so it will be like this, plus kf. Now what is the value of mt? Mt is am cos 2 pi fmt from equation number 3. So I will just write the value here, am cos 2 pi fmt. You can see the equation again. Yes. So I will just write placing value of mt from equation 3, right? Okay. And here it will be dt. Okay. It is just the same equation. 2 pi kf, 2 pi kf here. Okay, and then mt, just in place of mt I have written am cos 2 pi fmt dt. Okay, now come back to again this equation. So if I will put the limits, it will be 2 pi fc t minus 2 pi fc 0. So it will be 0. So I am just placing 2 pi fc t, right? Plus 0 to t, I can see what is common here. So I can just whatever is constant, I am just keeping it here. So it will be 2 pi kf am is constant, so I am taking it outside, right? And then inside what will remain? It will be cos 2 pi fmt dt, right? So theta it will be equal to 2 pi fc t plus 2 pi kf am. Now if I integrate cos 2 pi fmt, then it will be sine 2 pi fmt over 2 pi fm. Because why? Because we all know integration of cos nx equals to sine nx over n. So if we see this formula, so cos nx means cos 2 pi fm t. So x is basically t and n is 2 pi fm. So it will be sine 2 pi fm over n 2 pi fm, right? Now I integrated it. And I place the limits also t and 0, right? So if I'm placing 0, so it will be 0, and if I'm placing t, it will be t here. Now I can see what is like cancel out now. 2 pi and 2 pi is cancel out with each other, and okay, so I'm just cancelling out this thing. So what will be my equation, final equation? So it will be theta it equals to 2 pi fct plus kf am sine 2 pi fm t over fm. So please remember, you cannot cut this fm from this fm, right? You cannot cut because it is under sine. Okay, now what we can place, okay, this is the equation. We know basically delta f k, what kf, okay, so we know delta f equals to kf am, right? So if we know this, if delta frequency equals to kf into am, so what I will do, I will just place the values here. So it will be theta it equals to 2 pi fct plus delta f over fm sine 2 pi fm t, right? So this is the equation, and now this is the value of theta it, and what value I, okay, and I need to place this value in equation number 2 because I need the equation for phi fm ac cos theta it, right? So what I will read, what I will do, place the value of theta it in equation 2. So equation 2 is phi fm equals to ac cos theta I t. So I will just place this value there. So it will be phi fm equals to ac cos 2 pi fc t plus delta f over fm sine 2 pi fm t, right? So this is the final equation of frequency modulated waveform. So this is the equation for the frequency modulated waveform. Okay, now we will write the formula for the modulation index like we did in amplitude modulation, right? So when we are doing the modulation index, we know for frequency modulated waveform mf equals to delta f over fm. Okay, so this term is basically our delta f over fm. It's basically our modulation index, and we know that what is delta f. I explained you earlier what is delta f now, kf into am. So can I write it kf into am over fm, right? So this is the formula for the modulation index. Okay, next is, what is the formula for the bandwidth of frequency modulated waveform? So theoretically, basically bandwidth must be definitely infinite theoretically, but practically it is not possible. So I'm writing theoretically, but practically bandwidth equals to 2 delta f plus fm. Okay, so I'm just writing 2 delta f. Okay, so let us take delta f common. So I took the delta f common, so it will be 1 plus fm over delta f, right? And then, okay, what is delta f over fm? It is mf, okay, because MF equals to delta F over FM. So if I say what will be FM over delta F, it will be 1 upon MF, right? So can I write it here 1 upon MF, right? So bandwidth, the final formula for bandwidth equals to 2 delta F 1 plus 1 upon MF. Okay, so these are the formula for the bandwidth, modulation index, and the deriving the equation of the frequency modulated waveform. Thank you.